Bearings. Most machines depend on them for reliable operation. When bearings fail during operation, downtime can be long and expensive. In this program, we'll see that correct installation, effective maintenance, and proper storage and handling of bearings can extend their life and minimize unexpected downtime. Before we begin our discussion of proper installation procedures, let's look at some of the common problems that can affect bearings. One of the most common problems associated with bearings is damage due to heat. Usually, a hot bearing is a sign of a problem. Tight seals, tight internal clearances, any form of overloading, overspeeding, misalignment, or improper lubrication can raise operating temperature. Each bearing unit will have a different operating temperature, depending upon factors like speed, loading, and ambient temperature. Get to know what is normal for any unit, so you'll know when it's running hot. With a plain bearing, inadequate lubrication may allow metal-to-metal contact, producing friction and high temperatures. In a rolling element bearing, heat can mean that the bearing is completely dry, or it can mean the bearing is over-lubricated. Excess oil will churn, and its temperature will rise. In some systems, the lubricant is circulated to remove heat. If the oil seems to be at the right level, but operating temperatures are higher than normal, check to see if the oil is actually circulating. A blocked breather hole can sometimes result in false readings of the oil level. Tools such as this temperature probe will make checks of bearing temperature quick, accurate, and safe. Some bearings run hot enough to burn you, so using a probe is safer than touching the bearing housing. You should also listen to the noise the bearing makes. Sounds will often indicate the bearing condition. Experience can help because you can become familiar with specific machine sounds, or you can compare sounds to those in similar applications. In a plain bearing, knocks and thumps are an indication of slackness. With a constantly changing load direction, these noises will be naturally loud and easy to detect. The sound can also indicate excessive end play or end float in the shaft. A high tone or whine often means the bearing has been Brinelled. That is, the rolling elements have permanently dented the races. Random or intermittent clicks probably indicate a problem with the cage or retainer, damaged rolling elements, or dirt in the races. A crunching, grinding, or growling sound can also indicate dirt. Or it may indicate seriously worn rolling elements or races. Long before you are able to hear noises that indicate bearing problems, defects will produce vibrations that can be picked up by an ultrasound device like this one. In some companies, sophisticated monitoring systems are being used to record these ultrasounds. Over time, these records can provide an accurate indication of problems that are likely to develop. Sometimes, problems develop as a result of faulty or damaged seals. Seals have two purposes. They keep out moisture and dirt, and they retain the lubricant in the bearing housing. Any leakage should be investigated immediately, because it could mean that one of the seals has become worn, that the joint between the fitting surfaces of the bearing housing has loosened, or that the grease in the bearing has broken down and may not be providing adequate lubrication. Note the consistency of the grease. If it is hardened, it should be replaced. Note the color of the grease. If it is darkened, it may be oxidized, or it may contain particles, or it may have water in it. Take a little of the grease and rub it between your fingers. Check for any water present. You'll see it in small droplets. Look for any particles you can see. Very small particles will make the grease feel rough or gritty. Grease that is burned or carbonized means the bearing has been running very hot for some time. Any of these conditions may indicate the bearing has been damaged. Checking an oil lubricant follows much of the same pattern as for grease, but checks should be made more frequently. Systems that use oil generally operate at higher temperatures, and the useful life of the oil will generally be less. Bearing feel is also an indication of condition. A badly damaged or worn bearing will probably snag or feel rough as you turn it. Push and pull sideways and endways on the shaft and compare the feel to a new unit or a similar application elsewhere. If the bearing feels rough or loose beyond normal clearances, it is worn. Keep in mind that the more thoroughly you inspect bearings, the more likely you are to prevent unnecessary downtime later. Since many bearing problems can be traced to damage that occurred during initial installation, it is very important to know how to install a bearing correctly. New bearings taken from sealed, undamaged packages will not need to be cleaned. Any rust-preventative coating has no harmful effect on the lubricant. If you do need to clean a bearing for any reason, immediately afterwards, oil or grease it to prevent rust from forming. Make sure the shaft is clean and free of defects. You must also make certain that the shaft and bearing diameters match correctly. If a bearing is to be pressed into place, it must fit tightly to ensure full surface contact. Any dirt or burrs or any damage to the bore or the shaft may prevent full contact between the bearing and the shaft. This kind of damage can occur when removing an old bearing. For example, if not used correctly, the hooks on a bearing puller can scratch the bore. Before installing a new bearing, check to see if it has grooves or slots for oil or grease, and that any feed holes for lubrication are clear and clean, and that they line up correctly. Never attempt to drive a bearing in place with just a hammer. This will distort the bearing surfaces, probably making it impossible to mount the bearing correctly on the shaft or in the bore. A pilot driver, like this, will support the bearing inside and keep it from being distorted. However, whenever possible, you should use a press. Carefully align the press ram with the bore, and use a shouldered arbor or steel plate to make certain the bearing remains aligned with the bore as it enters. Never use a block of wood, because the force of the press may not be applied evenly to the top surface of the bearing. When installing a bearing on a shaft, you should apply oil or grease to ease assembly. Large plain bearings are often installed in half shells, like this. Installing these shells correctly is a precision operation. Initially, mark the housing in such a way that will allow you to reassemble correctly. Check the shaft or journal to ensure that it is not tapered, oval, scored, or rough. Always inspect and clean the back of the bearing and the mating surface in the housing carefully. Dirt under the bearing may reduce clearances and prevent adequate heat transfer. Usually, a dowel, screw, spool, or lug are used to keep the bearing in place and prevent rotation. If the edges of the bearing shell project slightly above the split housing surface, do not file them flush or try to shim the housing. The edges help secure the bearing in place when the housing is reassembled. Finally, always tighten the housing bolts to the correct torque. Like plain bearings, rolling element bearings must not be distorted during installation. Both rings must be firmly supported by a perfectly round bore and shaft. This means that when you remove a failed bearing for a replacement, you must be careful not to damage the bore or shaft in any way. Removing a failed bearing is often difficult. You may be tempted to break it off with a hammer, grind it off, or even use a welding torch to cut it off. These methods are dangerous and will usually damage the shaft or bore. The best practice when removing a failed bearing is to use a puller or a press adapter. The fit between the bearing ring and the shafts and bores is critical. If the fit is not tight enough, heat may not be properly transferred from the bearing. Also, vibration could cause the bearing to move or creep along a shaft or in the bore. Wear from this creep will gradually increase the slackness, and any slight vibration of the bearing in the bore or around the shaft can wear away fine steel particles, which rust and grind off more particles, destroying the surfaces of the bearing, shaft, or bore. The fit should be firm, or a push fit, as it is called. This allows the bearing to be installed or removed by hand, but just barely. There should be no detectable slackness. Manufacturers have devised a system of tolerances for both shafts and bores in order to ensure the correct bearing fit. Reference should be made to these charts when new bearings need to be installed. When the load and a bearing ring move together, the fit must be considerably tighter, or the ring will creep around on the shaft or in the bore. Inner rings are often locked mechanically. A common method is the use of set screws connecting through an extension of the inner ring. There are various kinds of locking collars. In some, the set screws go through the inner ring to the shaft. In others, a clamp squeezes the bearing's inner ring tight on the shaft. Large bearings often use a tapered adapter sleeve, the tightness of the fit is adjustable with the nut, which forces the bearing inner ring tight on the tapered sleeve. Press fitting is another common way of locking a bearing ring in position. The shaft is supplied slightly larger than the bearing's inner ring, or the bore is made slightly smaller than the bearing's outer ring. Press fitting a rolling element bearing puts very high forces and stresses on the bearing. If a bearing is pressed on incorrectly, it will be difficult to take it back off without destroying it. Or if pressed on incorrectly, a bearing may be only slightly damaged, so slight that the damage goes unnoticed, but the bearing still fails prematurely. In some cases, of course, improper press fitting can actually break a bearing. Keep in mind that some bearings, once installed, cannot be removed without destroying them. So always make sure that any retainer, seal, or shield that must go on the shaft behind the bearing is actually on the shaft before the bearing is installed. The bore or the shaft must be clean and free of any nicks, burrs, and slivers of metal which could become wedged in the chamfer at the edge of the bearing rings. When pressing a rolling element bearing into place, lubricate the parts to be pressed, then press with the right equipment. Press only on the ring being installed. For example, if you're installing a bearing on a shaft, press only on the inner ring. Do not press on the outer ring. And when pressing a bearing onto a bore, press only on the outer ring. If you do press on the wrong ring, the races and rollers are likely to be dented or brunelled by the force of the press. Press squarely. The press must be arranged to push the bearing on the shaft or into the bore absolutely straight. The ram must be lined up precisely with the shaft or the bore, and the force must be equal around the full circumference of the ring. Do not attempt to press with a wood block or any material that can compress unevenly or leave chips or splinters in the bearing. A brass plate or brass arbor is preferred, since brass is soft enough not to damage the surfaces of the bearing, but hard enough to push on the bearing accurately. Usually, there is a flange or shoulder that presses against the bearing to ensure that the bearing is positioned correctly. Shrink fitting is another method of mounting bearings, particularly large bearings. In this procedure, the bearing is heated. This causes it to expand enough to allow it to be installed without using a press. As the bearing cools, it shrinks tightly around the shaft. The bearing must be heated slowly and evenly. You can use an induction heater, an electric oven, or an oil bath. The temperature should not exceed 230 degrees Fahrenheit. If the bearing has rubber or plastic seals, take extra care not to damage them through overheating. If it is permanently lubricated with grease, you should check the manufacturer's specifications. Never use a welding torch to heat a bearing. The concentrated heat can crack or warp the bearing, and it may permanently soften the metal. If heating the bearing is not sufficient, it may be necessary to shrink the shaft with dry ice. Remember to wear the proper personal protective equipment and make sure you follow the proper safety precautions. If you use regular ice, it's important to protect the shaft with a plastic covering to prevent corrosion. Once you're ready to install the bearing on the shaft, work quickly. The temperatures of both the shaft and the bearing will equalize quickly. Since a bearing will sometimes move as it cools, make certain it's kept in place until the temperatures have equalized completely. Sometimes a shrink fit will expand the inner ring, reducing normal operating clearances and causing the bearing to bind. Make sure the bearing rotates smoothly after it is cooled. Rolling element bearings may also require lubrication at the time of installation. When this is done, it must be done correctly. Cleanliness is essential. Hands, tools, clothes, and the work surface must be absolutely clean. New, fresh grease must be pushed completely through the bearing from one side to the other in order to coat all parts. This can be done by hand, but it is preferable to use a tool to pack the bearing. If the bearing is filled with new grease, make sure there is some way for any excess to be expelled during operation. Excess grease may make a bearing run hot and could blow out the seals. After installation, it's always good practice to monitor the operation of a bearing when it is put back into regular service. When the machinery is started up, listen carefully to the bearing. There should be no abnormal noise. Keep an eye on the temperature. Usually it will rise at first, then slowly drop back to a normal running temperature after a few hours. Repeat these checks at regular intervals until you're satisfied that the bearing is operating correctly. Now, in addition to installing bearings properly, it's also important to store and handle them correctly. Occasionally, a bearing will fail due to damage that occurred even before it was installed. Bearings should not be stored in areas subject to dampness, vibration, magnetization, or extreme changes in temperature. New bearings should be kept wrapped and in their original box until you're ready to install them. New bearings should not be handled more than is absolutely necessary. They are coated with a protective film to prevent rust and corrosion. Do not remove this coating or store bearings dry, that is, without the protective film. Bearings rust easily. Since perspiration and skin oils are usually acids, even fingerprints can corrode a bearing. If a bearing is removed from equipment and stored for any length of time, pack it full of grease and seal it in a plastic bag with a label. This prevents air and moisture from coming into contact with the bearing metal. If equipment will not be used for a long time or is being transported, make sure the bearings are thoroughly lubricated. To keep all parts well lubricated, it is good practice to invert the equipment by hand occasionally. In this program, we have seen that when bearings are installed and maintained correctly, and when they are stored and handled properly, their operating life will be maximized. The reliable operation of industrial machinery depends upon bearings that last. If you follow these practices and procedures, unexpected downtime due to bearing failure will be minimized.